everybody, this is Miss Phoebus, and this is Lesson 27, Introduction to Polynomials, and then we're going to also combine that with polynomial addition and subtraction. So we're going to do two kind of things, and there's a lot of vocabulary going on in this lesson, so make sure that you understand the vocabulary. All right, so some new words that you might not know: polynomial, monomial, binomial, and trinomial. So if you know them, be able to define them. If you don't know them, we're going to define them in a second. All right, so polynomial is an expression, so there are no equal signs in this. Polynomial is an expression of more than two algebraic terms, especially the sum or difference of several terms that contain different powers of the same variable or variables. A monomial is the same kind of thing, except we have only one term. So I have an example here, like 3xy. That's one term, one piece. They are all being multiplied together, but it's one term. Monomials include numbers and variables that are multiplied together and variables that are multiplied together, and you can have exponents as well. A binomial is an expression in algebra that contains two terms. So 3x is one term, 5 is another. They are joined together with addition. And trinomial is an expression in algebra that contains three terms, like 4x squared minus 5y plus 18. 4x squared is one term, 5y, or actually negative 5y, is another term, and 18 is the third term. So the terms are broken up with addition and subtraction in between them. If there is no addition or subtraction, then there's only one term. It's a monomial. All right, so at the end of this video, hopefully you can define and recognize parts of an expression, such as things like terms. We are going to talk about factors, but that's going to be more in the next lesson that we do tomorrow. Coefficients are going to come up. We are also going to apply arithmetic operations of addition and subtraction to polynomials. Basically, can we combine like terms? And then identify that the sum or difference of two polynomials will always be a polynomial, which means that polynomials are closed under the operations of addition and subtraction, and then we'll get to multiplication later. So here are our standards that we're doing: interpreting the parts of an expression, and then understanding that polynomials form a system where they are closed. That means that when I add or subtract two polynomials together, I get a polynomial every single time. And we will add and subtract polynomials today. All right, so if you were in my group, you came to school on Monday, I gave you a set of notes. You don't need those notes, ladies and gentlemen, that were not here on Monday, but you can use them. So if you are in the notes, we're on page 115. All right. Monomials and polynomials, we're just going to go through. Again, monomial, a real number, a variable, or a product of a real number and one or more variables with whole number exponents. So whole numbers, those are counting numbers. Underline it, make sure you know what that means. So here are some examples, 18 is a monomial. It's just a number, but it's one term. X, monomial. Negative 4y squared, monomial. 2.5 x cubed y squared. That's a monomial. It has lots of pieces to it, but it's still one term. No addition, no subtraction. Let's see if I can write on this. So a over 2, that's how I would really like to write it. Let's try it again. A over 2, but notice the variable's in the numerator, so that is a monomial. Some non-examples: putting the variable in the denominator, like 3 over x squared. That's not going to work. Variables underneath square roots, not monomials. Do you see how in the next one, 0.25 is okay, but because the y is raised to a negative 2, so negative 2 is not a whole number. So because it's a negative exponent, it is not a monomial. And then x plus 4 over x minus 4, because that x is in the denominator, not a monomial. All right, polynomial where we attach different monomials together with addition and subtraction. So the number of terms in a polynomial is countable. That means I can't have infinitely many terms. I have to see an end. So I have to be able to count how many pieces, how many terms are in that polynomial. So here are some examples. 7x to the fourth plus 6x cubed plus 7. I can count them. There's 3 terms. 3p cubed plus 5p squared minus 7p plus 1. There are 4 terms in that example. 2ab is a term plus 3bc, that's a second term. So there are 2 terms in that last example. I can count them. Now, if it's going to be uncountable, if it's going to go off, there's like infinitely many, you're going to see like a plus dot, dot, dot. So let's turn this last example into a plus dot, dot, dot. Now that's not a polynomial because it has a part that is uncountable. You don't know where the dot, dot, dot stops. All right, let's clear. So how to find the degree of a monomial, and then this goes into also our degrees of our polynomials. So a degree is going to be kind of what power we're dealing with. So you're going to add all the variables' exponents together. If there are multiple variables, you will add multiple numbers. If there is no variable, just a constant has a degree of 0. And then the number 0 itself has no degree. So if I look at example 1, this is all about powers, all about exponents. So I have 5x. That x is to the first power. So this is a degree of 1. All right, 4 has no variable at all whatsoever. There's no variable. So it has a degree of 0 because there's 0 variables. All right, 6 has 2 variables. They both have an exponent, so we're going to add the 3 from the x cubed and the 2 from the from the y squared, and we're going to get a degree of 5. So multiple variables, you add their exponents. If there's only a single variable, you're just talking about what its exponent is, and if there is no variable at all, then it is a degree of 0. Okay, let's clear that out. One of the other things that we're going to be working with is standard form. So standard form, from now on, when you write your answers, all your answers need to be written in standard form. I'm going to start off reminding you, but that's going to kind of go away. That doesn't mean that standard form goes away. You're expected to write things in standard form, and that is the ordering of numbers in a polynomial starting with the highest degree and working your way down to the lowest degree. You may need to combine like terms. You can only combine the same variable with the same degrees together to simplify. So let's look at number 4, and let's see, is there anything that would need to be combined? I see we have some constant pieces. We've got this negative 14 and this positive 7. So negative 14 plus 7 is negative 7 plus 6x squared minus 9x to the fourth. So that's the very first thing I want you to do. If you can combine like terms, do it. All right, then the question is, do we have our biggest exponent? So we look at all of our variables. We want the biggest exponent first. So I see with my negative 7, there's no exponent. That's a degree of 0. With my 6x squared, there's an exponent of 2. So 2 is that degree. And then for my minus 9x to the fourth, the exponent is 4. So which one has the biggest exponent? The negative 9x to the fourth. Now you have to take the sign with it. So the sign that's right in front of it, you have to make sure you don't lose that piece. That happens a lot. So negative 9x to the fourth, that is first. It has the highest degree. The next highest degree is my plus 6x squared. You have to keep the signs in between the two terms. If you remove the sign, you remove the plus between the negative 9x to the fourth and the positive 6x squared, you remove that, you're now turning that 2 terms into a single term, and you're rewriting that problem. So make sure that there are pluses and minuses in between these. All right, so that takes care of this. So I have these 2 pieces, and then the one that's at the end has a degree of 0. It's the smallest degree. And so I have all my pieces in order from highest degree to lowest degree. It is in standard form. All right, so let's look at number 5. Do we have anything that we can combine like terms on? I see a y and I see a plus 2y. Let's combine them. So 1y plus 2y is 3y minus 4 minus y cubed. So now we want the biggest degree. Who has the biggest degree? Biggest exponent I see is this 3 on that negative y cubed. So that's what I'm going to start with, negative y cubed. If you want to put a 1 with that negative 1y cubed, that would work. Then the next biggest exponent is on this y. This is y to the first power. So y to the first power is going to go next. Now it's a positive 3, so I need to make sure I put a plus 3y. And then minus 4. And sometimes it helps if you like want to mark them out as you use them, so you can make sure you know what you have left, especially if you've got like a whole bunch of them. That is something that you could do. That is, I do find a little helpful. So that's getting it in standard form. Now, if you go to write an answer, you need to be checking, is it in standard form? If when you write it, it's already there, you don't have to make any changes. But if you notice that your degrees are out of order, you may have to do like an extra step. Okay. We're also going to name polynomials because I want to be able to walk up to you and say, hey guys, this is a cubic trinomial and we need to do such and such with it. And you're like, a cubic what? So I want you to make sure you know what I'm saying. So this is just, again, vocabulary. I want you to build this table on your notebook paper, or if you are in my notes, that works too. But we're going to start with degree, and the degree is going to give you the first name of the polynomial. So for the degree, we're going to write 0, 1, 2, 3, 4, and then 5 or higher. Now, the 5 or higher is going to be a way that we can write it. It doesn't matter if it's the 5th degree or the 9th degree or the 12th degree. We're going to be able to have a name for it. And then for our number of terms, that's going to generate a last name. So we're going to have a first name for our polynomial and a last name for our polynomial. So the number of terms we're going to look at is 1, 2, 3, 4 or more. And then when we get to that 4 or more, it's going to be a way to write it so that we can do 17 terms if we wanted to. All right, so the degree, and you may recognize some of these. So a degree of 0, the first name is constant. The degree of 1, the first name is linear. The degree of 2, oops, getting ahead of myself, quadratic. Degree of 3, cubic. So at this point in time, you should be like, hey, those are function family names. So constant, when we have x to the 0, I'll go ahead and tell you x to the 0 is 1. That means that there's no variable. Linear, all of our linear functions have an x to the first power or just an x. All of our quadratics are x squared and all of our cubics are x cubed. So there is a relationship between them and our function families. So that would mean these guys are x to the 4th, and we haven't talked about x to the 4th function families because that's more of an algebra 2 concept, but they do have a name. And it's the quartic function family. Now I'm going to ask you to be able to name these polynomials, and you can pull out this table. As you're learning their names, pull out the table. Now there are other names like the 5th degree, the 6th degree have special names. We're not going to go into that because we could spend forever on this. So what we're going to do is we're going to write that this is a 5th degree, or it could be a 12th degree polynomial. Whatever the highest degree is, just it's that degree. That just kind of cleans it up, makes it easy for all of us. Now, do not do this. Do not say, oh, it's an x squared. It's the 2nd degree. I have people that try to pull that on me. Nope. Don't you dare do that to me, because I want you to know it's quadratic. because we deal with quadratics, we deal with linears, we deal with cubics, we deal with all of those things, and I need you to know those vocabulary words. So do not call an x to the first power the first degree. That's technically true, but I want you using the proper vocabulary. All right, number of terms, we've already talked about these. One term is monomial. Two terms is binomial, kind of like bicycle. And three terms is trinomial, like tricycle. And then four or more, we're going to state however many terms. So there could be 4 terms. Say 4 terms, but it should be a 4-term polynomial. If it has 17 terms, it's a 17-term polynomial. Okay? So you're going to be building and naming these polynomials. They should have a first name and a last name. If I say, hey, what are you going to name your child? And, they don't have a first name and a last name, we've got some issues, right? So you don't just give somebody a first name, you also give them a last name. You don't just give somebody a last name, you also give them a first name. So you're going to be doing the same thing with your naming polynomials. Now, in this box here, what is the leading coefficient? We're going to bring that up. The first coefficient, so when I have everything in standard form, the leading coefficient is like the line leader. Who is attached to the biggest degree? And what number is the line leader in that expression? All right, so here we go. We're going to write in standard form. We're going to state the leading coefficient, and then we're going to name our polynomial. So we're going to do a little bit more than what we did in the last examples. So let's look. Is there anybody to combine? I don't see any like terms to combine. So now let's get it in standard form. We want to do that before we name it, before we state our leading coefficient. So the biggest degree, I think, is this 3w cubed. And then the next biggest degree is plus 3w squared. And then I have plus 8w plus 1. So everybody is in order, got their variables counting down, w cubed, w squared, w to the first, and then no w's. So then now I'm ready to state the leading coefficient. We're going to abbreviate LC, leading coefficient. So who is the line leader? Who is all the way to the left? I see a 3 right there. So no w's, just the coefficient. Coefficient is the number in front of the variable. So that is my leading coefficient. All right, so then now we're going to name the polynomial. We have a first name, we have a last name. So the question is, what is its first name? So where I look for first name is I look here. And you can go back and look at that table. I can't pull it back up because I've erased it already. You can go back and look at your table. And because that is a degree of 3, this is a cubic. And then I'm going to give it its last name. So now I count how many terms. So there's 1, 2, 3, 4 terms. So because there's 4 terms, it is a cubic 4-term, sometimes I put a dash, sometimes I don't, polynomial. Now some people are like, polynomial is a lot to write. Can I just write poly? I'm like, as long as you understand that poly is short for polynomial, I'm okay with that. All right, so lots of things going on. We dealt with standard form. Leading coefficient's pretty straightforward. Who's the line leader? And then now we're using that table. Can we name it? So you're looking in kind of 2 different areas. First name, what is the biggest degree, and what does that translate to into a first name? And then count how many terms there are, and then give it a last name. Now, if you do not combine like terms, you could possibly get the last name wrong because you counted everything and you didn't simplify before you started naming. Okay, so let's look. Number 7, do we have any like terms to combine? I don't see any. So then let's look at who has the biggest degree. I think it's negative z to the 6th. And then the next highest is plus z cubed, and then plus 4z. All right, let's get our leading coefficient. So who's the line leader? Now, we have just a negative in front. So we want to put a number with that negative. We don't want to just write negative. That doesn't make sense because that's not a number. But there is a 1 right there here, so it's a negative 1. That's our leading coefficient. All right, Then we're going to name it. So we're going to do first name and last name. You don't have to do the blanks. It's just a way to kind of help organize what we're doing. All right, so the first name is based off of this number. So go back and look at your table. We don't have a sixth line in there telling you that the sixth degree has a specific name. So the best we can write is sixth degree. Now I want to see the word degree. If you're going to get lazy on me and not write the word degree, you're going to lose points. And I don't want you to do that. I want you to get all your points. All right, so the sixth degree, and then we're going to count 1 term, 2 terms, 3 terms. So 3 terms has a specific name. We can't just write 3-term polynomial. It has a specific name. If you go back and look at your table, it's a trinomial. Okay, so we're using all this vocabulary and we're trying to understand what it means, what it's asking for when it's asking for specific things. All right, so I want you to try these. Pause the video, see what you can do. All right, I'm going to combine some like terms. I've got v squared, so I've got -2 plus 7v squared, that's 5v squared, plus 4v plus 8. Oh, look, it's already in standard form when I did that, so I don't have to make another step. I'm ready to go into the next part, which, what is my leading coefficient? What is my first name? What is my last name? So let's look at leading coefficient. Leading coefficient is the line leader. Who's in front? 5. All right, let's look at first name. First name is degree. Based on degree, I've got a 2 there, so that's quadratic. And then we're going to count 1, 2, 3 terms, so it's a trinomial. There you go. All right, let's look at number 9. I have some like terms to combine. I've got a -3x cubed. I did that first because I saw as the highest degree. So that is something that you can do. I'm going to combine these guys because they both have an x. So I've got plus 20x. Now notice that when I'm combining the variable with the exponent, that's not changing. What's changing is I'm adding or subtracting the coefficients. So only the coefficients are going to change. So if you're putting 15x plus 5x and you're getting 20x squared, that's not going to work. Squared or things that are changing exponents are going to happen because of multiplication or division. We're not multiplying or dividing right now. All right, so we combine like terms. I've got everything in standard form because I chose to do it that way. But if you don't, you would need to write it in standard form. And then we're going to do leading coefficient. And then we're going to name this guy. So let's see who's in front. Looks like -4. Let's get a first name. Oh, yeah, 3 is cubic. Let's count 1, 2 terms, binomial. Okay, so please, please, please have your notes, have your table out as you're doing your homework this afternoon or tomorrow, and be making sure you're getting that naming structure down. Now, I do prefer the degree first and the number of terms second, like first name, last name, but if you say it's a binomial that's cubic, that's not wrong. So it's just a little bit easier to say that way. So we're going to, it says shade each. This is something I do in class. We use like highlighters and stuff. You don't have to, but why don't you write these down, and then we're just going to see if it's a polynomial or not, why it isn't a polynomial. So if you want to write these examples down, and then we'll go through. So the top left is not a polynomial because it's uncounted. It's uncountable because it's got the dot, dot, dot. So it is not a polynomial. Okay, so top right, this is going to be not a polynomial because the exponent is a fraction. That's not okay for it to be a polynomial. And not a polynomial. Now, what an exponent that is a fraction is it's actually a square root. So really, you're dealing with the square root of x plus 2. Remember, we're not allowed to have variables under the square root. Let's look at the bottom left. I have x to the fourth. I've got a fraction, but it's a coefficient, not an exponent. So this is really x to the first. This is a polynomial. Right here, not a polynomial because it's got a negative exponent. So negative exponent. Not a polynomial. So this is what we're doing. I'm going to give you a few more to try on your own. See if can you figure out if it's a polynomial or not a polynomial. All right, so here are 6 more. Pause the video. Tell me, is it a polynomial or is it not a polynomial, and then give me a reason why. Okay, so let's look at the first one. This is really 3 over x. X is not allowed in the denominator, so variable in denominator. So that means not a polynomial. Now, people argue with me on number 12, or number 12, on 12. They'll say it's not a polynomial because it's a monomial. I understand that, but we're looking at, is it a polynomial, monomial? Is it in those families? So if we look at 12, we say, okay, it's a monomial. You know, is it a monomial? Does it break any of the rules? Does it have a negative exponent? Does it have a fraction as an exponent? Does it put a variable in the denominator? Does it put a variable under a square root? Is it uncountable? Any of those things. So it is a monomial. We're going to go ahead and say, well, we'll put it in the polynomial family. All right, let's look at 9 square root of x plus 2x. Not a polynomial because it has a variable under a square root. So not a polynomial. All right, what do you think about x to the first plus x squared plus x cubed? That is a polynomial. Nothing wrong with that one. All right, what do you think about the one with 5 minus 4 over x squared? Variable in denominator, so not a polynomial. In class, this would be more interactive. All right, what do you think about 5 minus 12? 5 minus x to the 12th? This is a polynomial. All right, so hopefully you're picking up on the rules of what makes it a polynomial, what makes it not a polynomial, and understand what's going on there. Okay, now we're going to look at naming some of these. If you are in the notes, this is in there, but I'm also going to add some pieces. So I do want to go back and kind of stress that leading coefficient part. So here we have some examples, and what we may need to do is we may need to write them in standard form. So let's look at polynomial 1. 5x cubed plus 4x to the 4th minus 2x plus 5. Is it in standard form? The answer is no. So let's get it in standard form. So the highest degree is going to be the piece that's the 4x to the 4th. I have a positive 5x cubed minus 2x plus 5. So now it's in standard form. What's my leading coefficient? Who's my line leader? My line leader is 4. Let's look at the degree. So the highest degree would be 4 because it's x to the 4th, and that would mean that this is a quartic. That's its first name. How many terms? 1, 2, 3, 4. So its last name is 4-term polynomial. All right, ladies and gentlemen, meet the 4-term polynomial that is a quartic. Quartic 4-term polynomial. All right, number 2. Is it in standard form? It is not. So let's rewrite it. So the negative stays with the x. So I've got negative x, and that's a positive 11. So what is my leading coefficient? What number is the line leader? It's a -1. All right, so let's look at our degree. This is x to the first power. Oops, I wanted that to be blue. X to the first power. So what degree is that? Go back and look at your table. Linear. All right, let's count how many terms. 1, 2. Go back, look at your table. What's its last name? Polynomial. All right, so how's it going? All right, you do the next ones now that you know what's going on. All right, so let's look at this. Now, before I even start, you see this +0 at the end? That's there for you to get rid of because you can simplify this down to where you don't have +0. We could add all kinds of things. Like this one doesn't have an x to the 6th or an x to the 5th. I could do +0 x to the 6th, +0 x to the 5th. That would increase my number of terms. I don't want anything that has to do with 0 to be around because it's going to affect my number of terms that I count. So get rid of anything that's got a 0. All right, let's get it in standard form. The highest degree looks like 2x to the 7th. The next one, -3x to the 4th, and then plus 4x cubed. So get rid of that 0 anytime it pops up. Leading coefficient, 2. Degree is 7. I'm trying to give away the answer for the next part. That means this is 7th degree. And there are 3 terms, and that makes it a trinomial. All right, what do you think about 19? There's no getting it in standard form, right? So its leading coefficient is 19. Technically, you could put an x to the 0 there, but x to the 0 is 1, so you don't need it. It is a degree of 0, first name constant, 1 term. This is a constant monomial. Here we have 3 more. See if you can pause the video and do them on your own. Oh, pause the video and try to do them on your own. All right, number 5 is already in standard form, so it has a leading coefficient of 5. It is a degree of 5 and 3 terms, so it is a 5th degree trinomial. All right, this one's not in standard form, so let's rewrite it. The 12x squared goes first. Plus 11, leading coefficient is 12. It's got a degree of 2 and 2 terms. That means it's a quadratic binomial. All right, again, we're just combining like terms. So I see we're going to have to do, I'm going to put my 12x to the 4th there. I've already used that. There was nobody to combine it with. Here I've got 3 plus 7's 10. So I've got plus 10x cubed. And then 5 minus 3 is 2x squared. All right, so I've got a degree of 4, 3 terms, leading coefficient of 12. This is a quartic trinomial. So it may be you have to combine 4 or 5 things, and you might get it down to a monomial. It just depends on your situation that you're in. All right, so if you are in the notes, we're going to jump to page 119, and we're going to add, subtract polynomials. And this is, again, just a lot of it is combining like terms. That's why it fits so well with what we're doing. You're going to make sure that you are, if you have to write your parentheses, if you have to write your polynomials, you're going to use parentheses. You're going to apply the distributive property when you are subtracting. You will combine like terms, and that means that exponents don't change because you are adding or subtracting. Exponents only change when you're multiplying. You guys aren't multiplying today. You're going to write your final answer in standard form. If it's not in standard form, you're going to get some points off. So make sure you're writing in standard form. Okay, so we are adding. Now when we're adding, you don't necessarily need to worry about parentheses, but this is just the first polynomial, which is a quadratic trinomial, and we're going to add it to the second polynomial, which is also a quadratic trinomial. Now when we add those polynomials together, we should get something that is a polynomial. We're going to check that. With the addition, you don't have to, like I said, worry about the parentheses. So let's just focus on combining like terms. I've got 5x squared plus 4x squared. 5 plus 4 is 9x squared. Then I'm going to do 2x plus negative x. So 2 plus negative 1 is 1. You don't need the 1, or you could just write x. And then negative 1 plus 2 is a positive 1. Now we started with 2 quadratic trinomials. We ended with a quadratic trinomial. Now you're not guaranteed that it's always going to be the same degree and the same number of terms as your originals, but it should be a polynomial, and it is. And it's written in standard form. How about that? Okay, let's look at number 2. So we've got y cubed. I always start with the biggest one, and I don't have any y cubes over here, so it's like adding 0 y cubed to it. So you don't have anybody to combine with it, you just write 3y cubed. All right, let's look at, I don't have any y squareds here, so 0 plus 1 is 1y squared, or just y squared. And the 0 idea is going to come in handy later on. Next up is y's. I've got 2 y's plus no y's. That's just y. And then I've got 1 plus negative 1. 1 plus negative 1 is 0. I don't have to write plus 0 in my final answer, so I have it in standard form. So this was a quadratic trinomial. Can you name number 2 really quick? It's a cubic trinomial. And you have to do that in your homework. You'll combine like terms, you will get this in standard form, and then you're going to name it. All right, let's look at subtraction. So with subtraction, it's a little bit different. The parentheses matter, especially the last set of parentheses. We're going to distribute this negative. It's almost like there's a negative 1 standing out in front of this parenthesis. We're going to distribute that negative first. Now there is another way to think about this, but this is the way that I want you, at least starting off, what I want you to start off thinking about. So the 5g plus 2 isn't going to change anything. The parentheses aren't needed. So let's think about a negative times a negative 2g squared. That becomes a positive 2g squared. A negative times a negative 3g is a positive 3g. And a negative times 4 is a negative 4. Then we're going to combine like terms. So I've got 2g squared. That's what I'm going to start with because he's got the biggest degree. And if you want to mark it out, you can. Then I've got 5g plus 3g. That's 8g. And then I've got 2 minus 4. 2 minus 4 is negative 2. Now, if you didn't distribute that negative, a lot of times what will happen is it'll happen to like maybe the first term, but then you forget about it. The signs on the other components are going to be wrong and possibly even the wrong numbers. So you want to watch out for that. But this is a quadratic trinomial. Yay! All right, number 4, they want us to set it up. So they're telling us how to set it up. They want us to subtract something from something else. Now, what I usually do, because order matters in subtraction, like adding things, it doesn't matter, right? Order doesn't matter. So subtracting things, I like to play around with the numbers. So let's say I'm going to subtract 10 from 20. That means that they want us to do 20 minus 10. They want us to do the 20 part minus 10. Now, where did 20 and 10 come from? They came from my head. I picked numbers. It could work with any number. Let's say I wanted to subtract 5 from 3. I would take 3 and subtract 5 because that's how the setup of the wording is. So that means I need to take the second one and subtract away the first one. Now, back in when we were writing the notes and the steps on how to do this, I said make sure you have parentheses. So you need to wrap 4c squared minus c. You need to wrap that in parentheses because it's one polynomial. We're going to do a minus, and this is the one where parentheses really count because you're supposed to distribute that negative. If you don't distribute the negative, you're going to end up getting the answer wrong. So I have to have the second set of parentheses here. Let me highlight them. These guys are necessary because you have to distribute. Have to. Okay, so that's like something that you need to highlight. This is important. So let's go ahead and distribute. So I've got 4c squared minus c. A negative times a negative is a positive c squared. A negative times a negative is a positive 1. Now we're going to combine like terms, get it in standard form. So that's 2c squared, so I can get together. I've got 4c squared plus c squared. That's 5c squared. Then I have a minus c and a plus 1. Okay, and then this is a quadratic trinomial. Lots of quadratic trinomials. Okay, so we're looking at how to add and subtract. With subtraction, those parentheses and that distributing the negative is very, very important. All right, so adding and subtracting polynomials, you can write them in 3 additional ways. So it is possible they can just set it up for you, or they can give you words, or they can give you something that looks like this. And it looks a little scary, but I'm going to explain it to you. So they could say, hey, we have these 2 polynomials, and we're going to name them f of x, and the other one's g of x. And we want you to add them together. And so that's that notation, that function notation. So it should look a little familiar. We could also, almost like grouping things, we can write it as f plus g of x. So these are saying the same thing, that we should take 2 polynomials that we're working with and add them together. So this is basically saying find the sum of f of x and g of x. And then subtraction-wise, same thing, except there's a minus sign between f and g. And then with subtraction, order matters. So if they give you g minus f of x, that's different than f minus g of x. Order matters. So you have to rewrite them out. And we're going to practice that in a second. But that is find the difference. So sum, add, difference, subtract. Okay, so here's the setup where you would need to know these things. So we have f of x, g of x, and h of x. And so they're setting us up for subtraction. Hopefully you can tell that. They want us to write the problem out ourselves. So we're going to start with f of x. Now you can write f of x in parentheses, but because it's first, the parentheses aren't necessary. So I'm going to write it without. But if you feel more comfortable adding those in there, you can. However, I am going to stress, when you do subtraction, the second one has to be in parentheses. If you don't use those parentheses, you're going to get in trouble. And I don't want that to happen. So we're going to put h of x inside those parentheses, because that's what we're subtracting. And then, once we have it all set up, now we're ready to distribute. So this is a way to get you to set up the problem, and hopefully you can do it correctly. All right, so I've got 9x squared minus 4x plus 2. That doesn't change. A negative times a negative is a positive 2x squared. Negative times a positive is a negative 3x. A negative times a negative is a positive 10. So all I did was I changed the sign on everything inside that parenthesis. All right, then we're going to combine like terms. I've got 9x squared plus 2x squared. 9 plus 2 is 11x squared. Then I've got a negative 4x and a negative 3x. Negative 4 and a negative 3 is a negative 7x. And then I've got a plus 2 and a plus 10. 2 plus 10 is 12. That is a quadratic trinomial. Again, it's a polynomial. After adding or subtracting, I should end up with a polynomial. All right, the sum. Sum means add. All right, so sum means add. We're going to put these together. So 9x squared minus 4x plus 2. Now, because we're adding, you aren't going to end up changing any of the signs. So parentheses are usually, like, if we were going to set this up for somebody, we would want parentheses, but in this case, parentheses aren't going to make a difference. So we're just going to combine like terms. There are no other x squareds, so I don't have to worry about that. I've got negative 4x plus 3x. Negative 4 plus 3 is negative 1x. And then I have 2 minus 1. 2 minus 1 is 1. I love these, with the exception of the vocabulary. It's just you're adding and subtracting. Love it. So we'll do one more example, and then we'll be done. So here, order matters. We're subtracting. We're going to start with g of x. G of x is 3x minus 1. We're going to subtract, and then we're going to put parentheses, 9x squared minus 4x plus 2. And then we're going to distribute here. So if you put f of x first and then subtracted g of x, you would be distributing into the wrong polynomial and get the wrong answer. So I've got 3x minus 1 minus 9x squared plus 4x squared, 4x, not squared, minus 2. And then now my 9x squared is negative, so make sure you write that first. Negative 9x squared. 3x plus 4x is 7x, and the negative 1 minus 2 is negative 3. So I'm going to be able to tell, are you putting parentheses around? Are you distributing the negative like you're supposed to? Usually I can tell because I'll be like, oh, you're close, but you're off by a little bit. It would be because your sign is incorrect. All right, so hopefully you've got some good notes on polynomial names, on how to get it into standard form, and how to add and subtract your polynomials. I'll see you in the next video. Bye.